All right, so we're going to do some problems. This is the binomial probability type of problem. Let's just see how it goes. For n is 65, p is 0.3, and x is 29. Find p of x. So there is a function in our calculator that will do this. StatCrunch can also do this. So we'll go to second, distribute, and we're going to go all the way down to binomial PDF. And we're going to put in the values. N is 65. P is 0.3. And the x value, I believe, was 29. Let's double check that. Yeah, the x value is 29. And now we're just going to paste this on the home screen. And we get 0.0045 or 0.0046. So let's plug that in. Can the normal distribution be can the normal distribution be used to approximate this probability? Well, there needs to be certain conditions need to be made, like the n times p times 0.7 should be greater than 10. So let's make sure that this is the case. So we're going to do 65 times 0.3 times 0.7 is 13. That's greater than 10. So let's just go with yes. Approximate p of x using the normal distribution. So okay. This part of the lesson actually should be canceled out. But I mean, maybe we can try to do it anyway. The problem is we need to be able to figure out what are the values that we're going to plug in to approximate it. So this is where it gets a little difficult. We need to know what are the values from this information that we were going to plug in. Okay. And yeah, so I'm recording a video right now, and I'm recording a video going over these problems just to kind of show how they're done. And so I did the first one pretty quickly. We used binomial PDF 65.3.29. We got 0.0046. We were able to say that yes, the normal distribution can be used because n times p times 1 minus p, which is 0.7, is greater than 10. This next part is actually kind of tricky. They want us to approximate the probability using the normal distribution. So this part is actually going to be harder to do, just because we would have to convert 29 into a z-score, and then from there we would have to use the normal function. So for these, it's probably be a good idea to skip. I mean, just because they weren't part of our lesson. Again, we can also do these problems on StatCrunch as well. But the part where it says approximate, I mean, we'd have to just go back, honestly, to maybe even pull up the textbook or our notes. So let's do that real quick. We'll go into our notes and just what I'll do is look. We'll get the formula for this. So that's actually kind of tricky. So let's go there real quick here. So our class notes, and we're going to pull up 7.4. And we'll go to the section. See, 7.3 was skipped. And I think in 7.3, there were things in 7.3 that talked about how to approximate you know, because 7.3 was skipped, they talked a lot about assessing the normality. So when we got to 7.4, there were some problems that kind of had, let me try to make this bigger. There were some problems that had snippets of 7.3 in it. And that was just a lesson that we're just not responsible for. So when it gets to a problem where, okay. Okay, so they want us to use, so we could use the normal distribution. NP would be the mean, and then for the deviation, we'd use this. So if I go back to my calculator, I would do, let's see. N times P, so we would do, let's figure this out real quick. This would be my mean, and then my deviation would be the square root of 3, the square root of 13.65. So there's my mean, there's my deviation, and now we're going to use those two values to approximate the normal distribution there. Let's see. Let's go back to the problem. So at 29, that's tricky. All right, let's try it anyway. Let's go to second, distribute. The X value will be 29. The mean will be, I just forgot what it was. I'll just put it in. And the deviation was the square root of and we're getting 0.0039, which makes 0.004 if we were to round it. So it actually worked, luckily. Oh, and we're not done. By how much do the exact, and keep in mind, we never use normal PDF. It's always normal CDF. But this is the one case where we actually had to use it, and that gives us the exact value, the X value there. So anyway, let's just try to finish this off. It looks like the last part. So by how much do the exact and the approximate values differ? So this is the difference of which are subtracting these. They're gonna differ by 0.0006. That's how much they differ. Let's see. Hopefully that's right. Okay, and let's do the next problem using StatCrunch. Okay, and same type of problem. So this time we're going to go into not view an example. Let's see. Not help me solve this. Get more help. Okay, there's StatCrunch. So we can pull up StatCrunch, and we need the calculator, the binomial. So we're going to go to calculator, but the binomial calculator, and our N is 40. Our P is 0.25. And the X value is 20, and it's exactly 20. So we're going to change that inequality to exactly 20. Compute, it did it for us immediately. 0.0004. They want 4 places there. Let's make sure, okay, we put everything in good. So 0.00 0.04. And can the normal distribution be used to approximate it? Well, that's only if when we multiply n by p times 1 minus p is greater than 10 or 10, then we can. So that's what we have to check next. We got to do 40 times 0.25. Actually, that's 10. And then 10 times 0.75 is 7.5. So when we multiply them three together, it's less than 10. So we're going to say no, it cannot. And since it can't, we're going to just stop right there. It cannot be used. And now, well, since it can't be used, then this must also be correct, okay? We multiplied those three together. Let's do another one. And this one probably will work. Look at our n. Our n is pretty large. So we're going to go back to StatCrunch. So we're going to go back to StatCrunch, and we're going to use that calculator one more time. This time the n is not 40. The n is 72. The probability is 0.82. And we're going to exactly 61. Compute, and we got 0.1074. Now the question is, what happens when you multiply all these? This will be too hard to do in our heads this time. So we're actually going to use our calculator, and we're going to do 72 times 0.82 times 0.18, because 82 and 18 must make 100. So we're going to hit enter. That's bigger than 10. So since it's more than 10, I'm going to say yes, the normal distribution can be used to approximate it. And now the question is, well, what is it when you use the normal distribution? Well, we can go back into StatCrunch. And here's where we're going to go back into StatCrunch, and we're going to go to calculator, but we're going to use the normal calculator, and we're going to put in the mean, which is 72 times 0.82. The standard deviation is the square root of, I probably have to, so it's probably going to be helpful if I actually did the calculations on the calculator and then plug them in. So the mean is 72 times 0.82. So I'm going to put 5904 for my mean. Now the standard deviation that should be used is going to be the square root of 72 times 0.82 times 0.18. .26 should be used. And our x value will be the exact amount. Our x value is going to be 61, but we have to set it to equal. Oh no, they don't give us that. They don't give us that value, but let's see what it does anyway. So if I put in between, though, I can put 61 and 61. So Well, let's see. Okay. So it looks like we're going to have to use our own calculator one more time. We're going to go to second distribute. Let me take off normal. I'll take off the stat wizard so we can go back to our home screen. Second distribute normal CDF. We're going to put in the mean 59.4, 59.04. Actually, I think they want our X value. Well, let's see. Standard deviation 3.26, and then the X value is 61. Hopefully we got the order right. 0.0043. Let me make sure we got the order right. Okay, the X value should go first. Yeah, that's what I thought. So let's delete this out. All right, now enter 0.1021. All right, now the difference between them, the exact one is greater by 50 point. All right, let me subtract that. 70.00. The exact probability is greater than the approximate probability by yeah, I mean, when you subtract them, you get 0.0053. I don't know why I didn't like that. Review the previous value. This is the approximate. There's the exact. Yeah, this has been very frustrating. I can remove some of these as well. 0.0055. Huh. Yeah. Yeah, that's too bad. I believe I did one of these on, let's see, on a helpful video. Or maybe I never posted it, but I did do one on a helpful video. And keep in mind, these questions do come from the textbook as well. And we have inside discussion, we also have available the student solution manual for the textbook. So if you find the problem in the textbook and it works it out with the student solution manual. Now, this only really works if it's an odd problem. But I actually have the even problems as well. If you happen to find a problem and it's even, I can provide the solution, the instructor manual solution as well. But here are the 7.4 problems. They're all kind of worked out. This is, well, this doesn't show much really. Yeah, I don't want you to spend too much time. If you do, then that's a sign that the homework problem is just, it's not a good assignment to really exercise on. But we can take a look at another one as well. If let's go back to which I think it was 11. Was there any more questions? So 0.89 would be the probability of success. Yeah, StatCrunch has been awesome. 112 flights are randomly selected, so that's our N value. So again, let's just go back to StatCrunch then. I don't know if it was already open or not. Well, it's open again. So we're going to go to Calculator, and we're going to use our Binomial Calculator. All right. And our N is 112. Our probability of success is 0.89. And they want us to, what is exactly 100 of those flights are on time. So 105 are exactly on time. That's 0.034. How many places do they want? 4 places. So 0.343. 0.343. Oh, I didn't see if I was right or wrong. Wait. 0.0343. Oh, they want us to use the normal approximation to the binomial. So when it comes to the normal approximation, when it comes to the exact value, StatCrunch doesn't have that, but the calculator does. The calculator has the normal PDF button, not normal CDF, but normal PDF. So for this one, we'd have to use the normal PDF. All right, let's just go over this one more time. It's going to be second distribute, normal PDF. There's 105, comma, the mean, which is 0.89 times 112, comma, the standard deviation, which is 112 times 0.89 times 0.11, and we're actually supposed to take the square root of all of that. So I'm going to insert in the square root function here. All right, you know, I'll put it in parentheses here. So this is the standard deviation. And now we're going to do insert square root. All right, so I'm just going to have to enter the whole thing in again. 112. All right, here we go. Let's try the whole thing again. Number one, the X value, since it's exact. Now we will be able to use StatCrunch for B, C, and D. We just cannot use StatCrunch for number A, the exact value. We should be able to though. So I'm gonna have to go back to StatCrunch and verify this. But for sure, for the at least and fewer and between, StatCrunch we will use. But for the exact, we're gonna use normal PDF. We're gonna put in the exact amount, 105. Now we're gonna put in the mean. The mean that is used is the number of flights times the 0.89. So 112 times 0.89. And now we have to put in the standard deviation, which is the square root of 112 times 0.89 times 0.11. And now close that off. And there it is, 0.0331. 0.0331. Yeah, it didn't give me the exact amount there. Wait, why did I go next? I don't want to go next there. All right, let's see if we can find the StatCrunch, the normal value there. We should be able to though. So it's kind of puzzling on why the normal, it didn't give us the exact normal value there. Maybe it will here. Yeah, maybe this is what we need. I'm not sure. Let's just double check. The mean is going to be 112 times 0.89. 99.68. No, this isn't even, it doesn't even give us an X value. It just gives us the sample size. That won't help. All right, let's try one more time. Something else here. Calculator beta. All right, let's get the standard deviation. It's going to be 112. Actually, I could just say 99.68 times 0.11. So 3.311313. 3.311313. And now here's the problem. So our X is 105. And if I put in 105, 104.99 and 105.001, this might do it. 0.0066. They didn't accept it. And they're not even allowing me to go on. So something's not right with this question here, sadly. Oh, wait, maybe, what, can we even use the normal to approximate it? N times 0.89, yeah, it's going to be more than 10. This problem has video support. But, I mean, that's not the problem. The problem is, how are we actually doing it? I think we know what to do. It's just not accepting it. It's the problem. But I'll play the video.
In this example, we'll learn to use the normal approximation to a binomial random variable. According to the American Red Cross, 7% of people in the United States have blood type O negative. What is the probability that, in a simple random sample of 500 people in the US, fewer than 30 have blood type O negative? First, let's verify that this is a binomial experiment. Each of the 500 independent trials here has a probability of success of 0.07. That indicates that this is indeed a binomial experiment. Now let's verify that n times p times 1 minus p is at least 10. N is 500, p is 0.07, times 1 minus 0.07. Again, you may want to use 0.93 when you get to your calculator. When we compute this, we get 32.55, which is indeed greater than or equal to 10. So that tells us we can go ahead and use the normal approximation. If we're looking for the probability that x is less than 30, fewer than 30 people have that blood type, recall that the interval must contain the endpoint, so we have to rewrite this as less than or equal to 29. The first whole number that's less than 30 is 29. We also have to make a continuity correction here. Since we're looking for 29 or lower, we make our adjustment by adding 0.5 to 29. So we're really going to be looking for the probability that x is less than or equal to 29.5. Now, before we can convert to z, we're going to need a mean and standard deviation. So let's begin with the mean. N, again, is 500, times p was 0.07. That computes to be 35. So the mean is 35. For the standard deviation, again, we have 500 times 0.07 times 1 minus 0.07. Real quickly, this expression in the radicand is exactly what we had to check before we could determine that we could use the normal approximation. So we've already computed this expression. It's equal to 32.55, and that's approximately equal to 5.71. So now we can go ahead, using a mean of 35 and a standard deviation of 5.71, to estimate this probability. So again, we're looking for the probability that x is less than or equal to 29.5. We want to change that to a z value. So 29.5 minus the mean, divided by the standard deviation. And I'm just going to write square root of 32.55 here to maintain our accuracy. But you could replace this by 5.71 if you'd like. When we compute this, we get negative 0.96. Okay. Let's turn to table 5, the standard normal distribution table. Negative 0.96. We're going to be working in this row that begins with negative 0.9. Move across the top till we get to the column that has 0.06 above it. And the area to the left, which is the probability we're looking for, is 0.1685.
Well, that was actually easy because there was the area to the left. We could use StatCrunch, we could use the calculator, but we were dealing with a problem where the x value was exactly equal to something. Like in our problem, it was the x value is exactly equal to 105. That's different from at least 105 or fewer than 90, or between 90 and 93. These we can do no problem. But when they say the exact amount, and they want us to use the normal approximation, it makes it a lot more difficult. So that's the hang up there. The other problems would have been really straightforward. We'd use our less than or equal to for 105, but I can't even go on because I'm restricted to move on. Even if I say, okay, this is wrong, I want it to be wrong, but I want to do the others. I don't even have the freedom to move on, and I apologize for that. But yeah, I mean, hopefully this was helpful. Let me see. Yeah, I'm a little puzzled as to why I didn't accept my answers there. We seemed like we had it in the normal PDF form. The normal PDF should have given us the answer as 0.0331. Nothing. It doesn't even, maybe 3.2, maybe just 3, nothing. So yeah, I'm a little stuck here with this one, but there were some problems that are actually kind of tough. Like number 20 was really tough. I remember I did that when I did a video on 20, maybe from 7.2 actually, now that I think about it. But some of the others, I probably will have to remove some of these problems. I know it's kind of been, many students have already done these already, but maybe we can do one where, well, let's see if this one will work out. So they say use the normal approximation of the binomial. So let's just try we'll try number 12. And and then after number 12, we'll look and see if there were any problems like this on the quiz that we should be alerted to, because I don't think so. But again, I'd have to double check for sure. So for this one, we're going to use the exact amount, and the mean is going to be 0.14. Actually, I should put back on StatCrunch, actually. Maybe that was the problem. Maybe I didn't put it in right again. So I'll be, yeah, in fact, let me go back to the original problem. Maybe that was the problem. The X value is 105. The mean was 112 times 0.89. This was, I'm just shocked that we got it wrong. So that's why I'm double checking everything. Number 11. Let me just check one more time. At exactly 105. And then the deviation is the square root of 112 times 0.89 times 0.11. Point 0.0331. They want 4 places. Nope. All right, so let's see if 12 does the same problem as well. 14% of patients gain weight as a side effect, and we have 636. So we're going to use this calculator again, and we're going to go to second, distribute. This time we're going to do number 1, normal PDF. The X value is exactly 90. The mean is going to be 639 times 4% times 14%. So, and the standard deviation will be 639 times 0.14 times 86. Point 0.0454. No. Hmm. Yeah, they didn't accept that one this time as well. All right. And as far as, so